I'm really excited to introduce our next opening plenary speaker this afternoon, morning or evening, depending on where you are. Our speaker was born and grew up in Hong Kong and studied and worked in Canada and the UK before settling in at the University of British Columbia in Vancouver as professor and research chair in ocean sustainability and global change at the Institute for the Oceans and Fisheries. And I'm also pleased to inform you that he has just been appointed as the director of the Institute. Our speaker has a very impressive CV. From 2013 to 2020, he was the director of science of the Nippon Foundation Nereios program. It is an international interdisciplinary program that includes more than 20 partner institutes with the goal of predicting the future oceans using both natural and social science approaches. He also has received various international and national awards and other honors, including the EWR Istizzi Fellowship that was awarded last year, 2020, the Prix d'Excellence awarded by the International Council for the Exploration of the Seas, that was in 2018, the Ihor Boyanovsky Academic of the Year Award by the Confederation of University Faculty Associations of British Columbia, also in 2018, and he was recently amongst the 20 world's top climate scientists listed by Reuters. His work cut across multiple disciplines, from oceanography to ecology, economics, and social sciences, and ranged from local to global scales. His current research focuses on using scenarios and models to understand and project the responses and risks of marine-coupled human-natural systems to global change, and thereby to explore solutions and options to meet the challenges of sustainable ocean management under climate change. With his extraordinary CV and background, he will share with us his expert opinion on the future of seafood resources and the role of cooperation in line with the theme of this conference. Without further ado, please help me in welcoming Dr. William Cheung to the virtual stage, and I request you all to give your full attention. Dr. Cheung.
Thank you very much, Noah. Good morning, good afternoon, or good evening, depending on where you are. Let me share my slide. First of all, thanks very much, Noah, for the introduction and very kind words. I would also like to sincerely thank the organizer for inviting me to speak in this conference. Before I go to my talk, I want to first of all do some acknowledgement. I'm based at the Vancouver campus of the University of British Columbia. So I want to acknowledge that I'm presenting on the traditional and unceded territories of the Musqueam, Squamish, and the Tsleil-Waututh people. The theme of this year's conference is cooperation. In my talk, I will explore further this theme, and particularly from the perspective of the future seafood resources in a changing climate. In fact, this year's theme relates closely to what we do in our institute, the Institute for the Oceans and Fisheries at the University of British Columbia. We aim to secure healthy and sustainable marine and freshwater systems through interdisciplinary research, education, and societal engagement. And many of our works are directly linked to and supporting policy discussions internationally and locally, and often through cooperations with partners from different sectors, stakeholders, knowledge holders, and countries and communities. Oops, I forgot to change my slide there. Okay. I have three main focuses in my talks today. First of all, I will explain to you large global disparity in the sustainability of future seafood resources. In fact, when I was preparing for this talk, I asked myself, what are the scientific frontiers that would help address such global disparity, particularly in relation to the need for international cooperation? I will not be able to provide an exhaustive list, but instead, I picked three topics that I'm particularly passionate and am currently pursuing in my research. These relate to elucidating impacts, identifying policy levers, and finding solutions that fit local context and needs. Finally, I will discuss how we can foster cooperation, particularly through sharing of data and knowledge, and how the use of scenarios and models can play a role in facilitating these cooperations. Seafood is very important for us as a source of food, livelihood, income, and is also an important part of our culture. Global demand for seafood has been increasing in the last 50 years. This is a result of the continuous increase in consumption per capita, as well as the rising global population. However, there are large regional differences in the importance of seafood to support people's well-being. For example, in tropical developing countries, they are generally much more strongly dependent on fish as a source of animal protein. Based on recent study, this also applies to other important micronutrients that are from seafood, such as calcium, iron, and omega-3 fatty acids. And a lot of the time, those are the only sources of, seafood is the only sources of these micronutrients for people in some of these coastal communities. At the same time, countries that are most dependent on fish as a source of food are also amongst the lowest income and level of economic development countries. This is a map of gross domestic products per capita, which is an indication of the level of income and economic development. These maps highlight two things. Firstly, the ability for tropical developing countries to substitute seafood with other food production sources when seafood resources is not available are much more limited than other more developed countries. Secondly, relatively speaking, seafood and related sectors plays a more important role in the pathway to support the economic developments of these countries. Some countries, for example, Indonesia, explicitly express and include seafood sector as the main driver for their economic growth. However, the supply of seafood is limited. In fact, we have already reached the peak fish. Global fisheries catches increased continuously from the 1950s to the 1990s. It then started to decline. This figure is based on the sea around us catch reconstruction data. In fact, many fish stocks around the world are considered overexploited, and the remaining are fully exploited. There has been a lot of enthusiasm in aquaculture. When we look at mariculture, which is marine aquaculture only, it has expanded substantially in the last few decades. But even if we include the productions from mariculture, it cannot reverse the declining trends of seafood supply in recent decades. Also, much of the expansion of mariculture is concentrated in a few countries, such as China, or the production or concentrated on the production of high-value finfish, such as salmon, that target specific markets, mostly in more developed countries. Adding to the challenges of seafood resources availability is the impacts of climate change. This is from the recent assessment of the IPCC Special Report for the Oceans and Cryosphere. This table summarizes the evidence of observed impacts on the natural and human systems in the oceans. The column represents different ocean regions, while the different rows represent the different natural and human systems. Red color refers to negative impacts. And if we look closely and only at the role for fisheries, climate change impacts on fisheries are already observed in all major ocean basins. The impacts also vary by regions. Projecting into the future, climate change impacts are expected to intensify the global disparity in seafood resources that we just talked about earlier on. Again, this is from the IPCC Special Report for the Oceans, and this figure is a series of the projections of the CIMIC 5 Earth System models projections, as well as the outputs from the fisheries and marine ecosystem models. Overall, large net pie production is projected to decrease in the tropical oceans. Also, ocean warming, polar redshift of species, drive biomass and potential catches decrease in the tropical oceans. And such global disparity is a result of the characteristics of the climate hazards combined with the different sensitivity of the species in different regions. In addition to the differences between the natural systems, there are also telecoupling linkages between the tropical and extratropical regions through the human systems, which drive some of these global disparities. This is a schematic diagram that we produced in a review paper recently, which is led by Vicky Lam. We identified examples of major telecoupling pathways that interact between the natural and human systems. We highlight examples of such telecoupling pathways. For example, the distant water fishings in the high seas or other countries' EEZs in the tropics by countries in the extratropical regions. Also, there are global supply and redistributions of seafood through global trade. So overall, the key message from here is that there are global disparity in the availability of future seafood resources in a changing climate, and this poses a major challenge for sustainable development. So next, I want to look at different ways that we can address this disparity. And firstly, it is important to elucidate the disparity of emerging human impacts on seafood resources. To illustrate this, I will talk about a project that I am pursuing as an example. There are many other examples that are equally or more important. But this example is a study of the impacts of temperature extremes on fisheries and dependent human communities. Marine heat waves are having large impacts on both natural and human systems and have been reported in major ocean basins all over the world. Some of the more well-studied ones are the effects of heat waves on coral bleachings and the effects of some of the heat waves for example, in the Northeast Pacific region. Marine heat waves are projected to increase in frequency and intensity in the 21st century. And again, the latest scientific assessments, such as this one reported in the IPCC report, suggest that the tropics are amongst the hotspots of marine heat waves. However, the pathway through which and the details of how marine heat waves are threatening fisheries and dependent human communities are still uncertain in most regions, particularly in the tropical region. Here in this particular research that my collaborators and I are working on, we use an integrated model to elucidate the global impacts of marine temperature extremes on fish and invertebrate stocks and assess the implications for dependent human communities. We account for the effects on biomass, shift in distributions, potential catches, and their effects on food, revenue, and jobs. To characterize temperature extremes, we use the Earth system model projections, especially through the large ensemble simulations. And for fish and invertebrates, we use the dynamic bioclimate envelope model that our team have been developing in the last decade or so. This is linked to the shared socioeconomic pathway that specify the societal drivers, such as population growth, GDP, seafood consumptions, that would also affect seafood resources. These drivers are then combined with the biological projections to simulate changes in price, revenues, and fishery-related employment, using these indicators to elucidate the societal impacts. I won't go into the details of the method, but please feel free to talk to me if you are interested to know more about this. To give you an idea of what the results look like, I'm showing you a projection for a particular region, for a particular species. And the high temperature extremes here is representing the USA West Coast for the California anchovy stock in there. The high temperature extremes, as indicated by the red cross, here are projected to add on top of the decadal scale mean warming, which is indicated by the black line there. This is then translated to the impacts on fish stocks. For example, in this case, the decrease in biomass because of temperature extremes is at least double the decadal mean change impact. Such impacts also amplified the estimated decrease in fishery revenues, when projected fish price changes in fish price are considered. We then ran simulations for thousands of fish and invertebrate stocks in the world. We found global disparity in the socio-economic impacts of marine temperature extremes. This map highlights areas where revenues are projected to be substantially impacted by temperature extremes. And in this case, the highly impacted countries include those in the tropical areas, such as Central America, Africa, and Indo-Pacific regions. And these countries are already at high risk to decadal scale mean change, which is shown on the map on the right-hand side. Similar general results of global disparity have been found from our simulations when we look at fishery-related employment as an impact indicator. So what this shows is that developing countries are much less equipped to deal with the large episodic impacts, where the impacts are a lot of those impacts are occurring. And we know from our current experience of the COVID-19 pandemic how large episodic shocks can really impact societies, particularly when they are not prepared to respond to it. And thus, international cooperation to enhance knowledge and societal capacity is important, in this case, for these tropical developing countries to deal with these urgent needs for preparing for the responses. The second frontiers I want to briefly talk about is to identify policy levers to address these global disparity in impacts. Particularly, I will talk about an example that relates to fisheries subsidies and carbon sequestration. How do these two relate to one another? This example is based on a study that is led by Gail Mariani. In this study, we hypothesized that large pelagic fishes such as tuna and sharks contribute to sequestration, carbon sequestration at their body, they die and their bodies sink to the sea bottom. The carbon carried by this dead body is then buried in the sediment and stay there for a long time. However, fishing releases this carbon as we consume the fish. At the same time, industrial scale fishing activities use fossil fuel that also directly contribute to carbon emission. We use global fisheries data and develop an algorithm to account for the carbon that are released from fishing of these large pelagic fishes. We find that overall, overfishing lead to more than 20%, more than 20 megatons of carbon not sequestered to the sea bottom, and their fishing activities burn and release more than 160 megatons of carbon. Biomass of these oceanic pelagic fish are highest in the tropics also. However, they are caught by only a handful of countries, mainly, for example, in Japan, South Korea, Spain, and USA, fishing in these tropical waters, and they are not tropical countries. The only reason why these fisheries are profitable is because of government subsidies. We combined our estimates with global datasets of subsidies. We found that 44% of the carbon extracted by fishing these large oceanic predators come from areas that would otherwise be economically unprofitable without harmful fishery subsidies. By harmful fishery subsidies, we mean subsidies that support fishing capacity. Although the estimated carbon sequestration potential from large oceanic predators here is low relative to other pathways, but there are large co-benefits associated with more sustainable fisheries. Also, this example illustrated that a policy lever, and in this case, eliminating harmful subsidies, can also reduce global disparities in impacts through telecoupling that I mentioned earlier on. The third and final example that I will talk about is related to finding solutions that fit local contexts. I will use an ongoing collaborations between my university, the University of Bern, the Packet Foundations, World Bank, and the Indonesia's Ministries of Fisheries and Marine Affairs as an example. This example also highlights how such collaborations and cooperations between international organizations, foundations, academic institutes, and local governments can help find effective climate solutions. Indonesia, like many other tropical countries, are projected to experience large climatic hazards in the oceans. These include ocean warming, acidification, deoxygenations, changes in nitrite productions, for example. In addition to the decadal scale mean change, Indonesia is also facing severe risk from heat waves. For example, this is an analysis using the newest high-resolution climate models. And we projected that by 2030, majorities of the waters in Indonesia will be experiencing heat waves-like conditions throughout the year. This will have impacts, for example, on ecologically and socio-economically important coastal habitats, such as coral reefs, mangroves, and seagrass. Fishery resources are also projected to largely decrease, particularly under the no or little climate mitigations. These are projections using our bioclimate envelope models, dynamic bioclimate envelope models that I mentioned earlier on, that simulate the changes in potential fisheries catches of major fish stocks that are important to Indonesia's in the 21st century under different scenarios of emissions. We communicate these assessment and scientific studies to local stakeholders and knowledge holders, and as well as policy makers through the organization and the use of participatory workshops. These workshops discuss in these workshops, we discuss, besides communicating our findings, we also discuss with the local stakeholders about their priority concerns for climate change, and also try to identify ways to address these impacts. And through the cooperations and co-developments of this knowledge, we also help develop local capacity to understand and apply these data and information to support their policy development and implementation. And ultimately, the goals of the project is to support the development of Indonesia's national adaptation strategies for fisheries. For example, we develop visualizations such as infographics and videos to help communicate our scientific assessment. Here we depict two scenarios of futures of Indonesia's oceans and fisheries. We have the brown fish and the green fish scenarios that depict the two scenarios with a more sustainable development and a more business as usual scenario. This is also accompanied by a video, and both of these communication products are translated to local languages. We have just completed our second workshop. In these participatory workshops, we discuss specific adaptation pathways and strategies with local stakeholders to identify that we identified by the same participants in the first workshops. We then examined the potential effectiveness, trade-offs, and co-benefits of these strategies at the individual level, at the sectoral level, and at the institutional levels. We are still analyzing the results from our second workshop, but we find that this kind of process can really help facilitate co-development of solution options that can meet the local needs, and thus increasing the chance of uptake and implementations by the local authority and stakeholders. Finally, I want to highlight a few strategies in general that can help foster cooperations to develop capacity and identify solutions. Well-designed data infrastructures and data services can be effective in sharing of data and knowledge. This is particularly the case when the use of these data and services are supported by appropriate training and capacity development. I'm putting two examples here as an illustration. I'm sure many of you are familiar with these two examples. The first one is the CRNS database for global fisheries, and the second is FishBase and including sea life base, which is a database of all sorts of biological information for fishes and invertebrates. And they have been available and developed for decades. And throughout these years, they have been supporting scientific assessment as well as informing policies in countries and different institutes all over the world. And they also provide training to support the use of the data that they presented in the data services as well as the data infrastructure. So this gives us some example of the usefulness of these data infrastructures in sharing of data and knowledge. Another thing that I also want to highlight is that there are lots of recent advancements in the use of participatory scenarios and modeling to engage with local stakeholders and participants to co-develop priorities and solutions for various environmental challenges. And in this particular case, we have developed and applied these scenarios and modeling to look at the climate change challenge. And we find that this is a really good method for breeding of different knowledge systems, the scientific knowledge, local knowledge, traditional knowledge across different scales to then try to learn from each other about the properties of the systems, what are the challenges they are facing, and through that identified appropriate and priority solutions that can really address the local needs. And these two are the examples that we have worked on in our research. For example, a study that we conducted in Mombasa in Kenya, and a study that currently ongoing that is working with the coastal First Nations people in British Columbia. So in summary, in these presentations, I try to highlight that there are global disparity in the sustainability of seafood resources in a changing climate, and that this disparity needs cooperations between different countries, between different disciplines, between different knowledge holders, between different cultures to address. And such cooperation is important for elucidating, in terms of elucidating human impacts, identifying effective policy levers, as well as developing solutions that meet local needs. And finally, I suggested that such cooperation can be facilitated by the use of innovative data infrastructure, accompanied by appropriate capacity building and training of the use of these informations, as well as the use of scenarios and modeling, participatory framework and tools to facilitate these cooperations. So with that, thank you very much.
Thank you very much, William. Do you have any, thank you very much for the very informative talk. Yes, and I would like to ask if somebody has question, they can, you can put it on chat. Or any comments? So the comments are, thank you for this great talk, yeah. And Dr. William Cheung, do you think, how can we promote more cooperation to find solutions, especially for in problems of different developing countries?
Thank you very much for the questions. I think, and based on my, I think one of these things, there are many things that are important in facilitating these, facilitating cooperations in addressing this sustainability challenge. And one of the things as a scientist is important is to listen. I think that's something that I learned through my experience. I made many mistakes, and over the years, that's how I learned it. Is that we often think that we have, as a scientist, have developed new knowledge, state-of-the-art knowledge that we want to communicate to local people, local stakeholders who are in need of these solutions. But then a lot of the time we forgot that we need to listen to what the priorities and the needs of the local people first before we making a decisions of what kind of information they need or what kind of solutions options they need. Because there are effective solutions that really need to fit with the local context, and that there are things that we don't know that may have preventing from the upticks of particular options or the effectiveness of the options, or even lead to some trade-off or negative consequences associated with a certain intervention that you want to propose. So I think listening to what the people's needs, as well as the perspective about the changes, are important first step in facilitating the effective cooperation.
Okay, thank you very much. I have also a question here. How is your use in participatory approaches influencing your science?
Yeah, so I think this is so the participatory approach is one of the tools that allow us to formally provide a formal way to listen to the feedback of listen to the stakeholders and local people, and then you be able to then have a way to use those information to inform our research, to provide information that would fit the local needs. And so this is one usefulness of the participatory approach. Another usefulness is that participatory approach is also a good learning tool, both for us as well as for the local people, because through this process of discussion, for example, about the local socio-ecological systems of seafood and fisheries, and how climate relates to fish availability, to people's fishings and their consumptions and their culture, we learn much more about the complexity of the systems, both from the perspective of the scientists as well as from local people. And this allows them to allow us to explore new options or opportunities or knowledge space that we haven't learned before. One of the examples is that in the study that I showed earlier on, or the picture that I mentioned, the study in Mombasa, Kenya. We did a participatory approach, scenarios and modeling approach. And through that process, we identified trade-offs between, in this particular case, women traders, fish traders, and the conservation and management measures in place in the Mombasa area that no one have thought before. We call that taboo trade-offs. And so that really inspired people to think about the need to address this group of people in the communities that are missed out in the previous exploration, and also identify ways to deal with these kind of trade-offs.
Okay, we have one more 1 minute left, and I have a question here from Ajit. So Ramaniam, I would like to get your sense of how to fix the transfer in carbon between the developed and not so developed countries. Will something like a carbon-based revenue transfer work?
This is a really big questions, and I have to confess I'm not I'm not knowledgeable enough to propose ways to deal with this big challenge. How to deal with the global equity and in sharing of the carbon mitigations and the needs for that. But I think one thing that we find is that in looking at conservation measures, for example, in the study that we published earlier this year with other colleagues, we look at how marine protected areas can contribute to both biodiversity conservations, fish protections, as well seafood protection, as well as carbon sequestrations. We find that if we are able to do a coordinated efforts around the world, we will be much more efficient in protecting our areas, in achieving these three important societal objectives. And that's really required cooperations between countries, particularly seeing how the developed countries will support the developing countries in identifying and supporting the effectiveness of these conservation measures while meeting the local needs.